Hey, Class 10. Today, we're going to tackle a topic that's pretty much guaranteed to show up on your exams, the power of a lens. We're going to make this so simple. You'll be able to solve any problem they can throw at you. So let's jump right in. Have you ever looked at your glasses prescription and seen those numbers? That plus 2.0 or negative 1.5? Well, that's it. That's the power of the lens, and it's exactly what we're going to demystify today. This is physics you can actually see and use in your everyday life. All right, so first things first, what do we even mean when we say lens power? At its heart, it's a surprisingly simple idea. Let's dig in. Okay, check this out. The whole concept really boils down to this. Think of a lens's power as, well, its strength. A high-power lens is like a bodybuilder. It bends light rays a whole lot, focusing them really quickly, and because of that, it has a short focal length. On the other hand, a low-power lens is much more gentle. It just bends the light a little bit, which means it takes a lot longer to focus, giving it a long focal length. Now, here's the official textbook definition you'll want to have in your back pocket for your exams. The power of a lens is just the degree to which it converges or diverges light. But the real key, the part you absolutely need to remember, is that last phrase. It is the reciprocal of its focal length. That one relationship is the secret to the entire formula. So we've got the concept down, now let's get to the tool you'll actually use to solve problems, the formula. And trust me, for lens power, this is one of the most important and straightforward formulas you're going to learn. And there it is. Looks almost too simple, right? P equals 1 divided by F. Power is the reciprocal of the focal length. You can literally think of them like two kids on a seesaw. When power goes up, focal length has to come down. When the focal length is really long, the power is low. They're complete opposites, and this tiny formula unlocks everything. Okay, so the formula is easy, but here are the rules of the game. And I'm telling you, this is the #1 spot where students make mistakes. That F, the focal length, it has to be in meters before you use the formula. If they give it to you in centimeters, you have to convert it first. Got it? And the unit we use for power, it's called the diopter, and we just write it as a capital D. All right, next up is something that can totally make or break your answer in an exam. The sign convention. Yep, whether the power is a positive or a negative number depends completely on what kind of lens we're talking about. And the rule is actually super straightforward. A convex lens, the converging one, is always our positive guy. It has a positive focal length, which means it has a positive power. A concave lens, the one that diverges or spreads light out, is the opposite. It always has a negative focal length, which gives it a negative power. Seriously, burn this table into your brain. It is the key to getting the signs right every single time. Okay, enough theory. The best way to really learn this is by doing it. So let's apply everything we just talked about and solve a classic exam-style problem together, step by step. Here we go. Here's our mission. This is taken right from your textbook material. We need to find the power of a concave lens that has a focal length of 2 meters. Seems simple enough, doesn't it? Let's break it down. The very first step in any physics problem is to pull out the clues. What information have we been given? The question tells us 2 critical things. The lens type is concave, and the focal length is 2 meters. And hey, bonus, the focal length is already in meters, so we don't even have to do a conversion. Perfect. Now for the most important step before we even think about touching a calculator, the sign check. We just learned that concave lenses have what was it? Yep, 8 negative focal length. So we can't just use 2 in our formula. We have to write it down as F equals negative 2 meters. This little detail is what separates a right answer from a wrong one. And now we get to do the easy part. We just plug our values into the formula. Power equals 1 divided by F. So that's 1 divided by negative 2. The math is simple, right? It gives us negative 0.5. And don't forget the units. The power is negative 0.5 diopters. And there you have it. The final answer is negative 0.5 D. See? By following those simple steps, identifying the clues, checking the sign, and then doing the calculation, you can solve these problems with confidence every time. Okay, let's do a super quick recap of everything we've learned. Think of this as your ultimate cheat sheet for the power of a lens, perfect for that last-minute revision right before your exam. So let's lock in these key takeaways. 1. Power is just how much a lens bends light. 2. The formula is super simple. P equals 1 over F. 3. This is the big one. Focal length must be in meters. 4. The unit is the diopter, or D. And finally, 5. Convex is positive, concave is negative. If you can remember these points, you are absolutely ready for your exam. And that is the power of a lens, completely simplified. Nailing fundamental concepts, like this one, step by step, is the absolute best way to build your confidence and score high on your physics exam. If this explainer helped clarify things for you and you want some more support to get fully exam ready, we've totally got you covered. A1 Institute offers everything you need, from comprehensive notes that cover the entire syllabus to expert guidance from experienced teachers. And if you're looking for admissions help, we can do that too. Our phone number is right down in the description below, so get in touch for admissions, notes, or any expert guidance you need. For more exam-ready explainers just like this one, don't forget to like, share, and subscribe to the A1 Institute channel. Thanks for watching and good luck with your studies.